So not only can we reflect and translate points, we can also rotate them. So we're going to start just by talking about a 90-degree rotation. So let's say I'm going to have a point, and I'll have my original point P will be at 2, 3. So it's going to be right here in the first quadrant, 2, 3. So here's point P. So the rule for taking a point and rotating it 90 degrees counterclockwise, we are going to take the y coordinate, multiply it by -1, aka change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. And then with that changed y coordinate, then we're going to interchange them. We're going to switch them. So we're going to make the y, change the sign of the y, and then send it to the front. So multiply by -1, and then it becomes the x coordinate, and your x coordinate becomes your y coordinate. So you're not changing the sign of your x coordinate, you're only changing the sign of the y coordinate before you switch them. So if my point P is going to get rotated 90 degrees, I'm going to take the y coordinate, multiply it by -1, and then send it to the front. So 3 times -1 is -3. Then I'm going to send it to the front, and then I'm going to send the x coordinate to the back. So my new point P prime is going to be at -3, 2. Okay, so I just rotated that point 90 degrees. So now I'm in the second quadrant. So let's say I wanted to rotate it again 90 degrees to get P double prime. I would take my y coordinate, multiply it by -1, send it to the front, so it'll be -2, and then send the x coordinate to the back, so -2, -3, which will put me -2, -3 right here, which looks like I rotated it 90 degrees again. So 90 degrees, 90 degrees. Oh my gosh. Is it rotating 90 degrees twice the same thing as rotating 180 degrees? Interesting. Notice, how did I get straight from P to P prime? To get from my point to my point where after I rotated it 90 degrees twice, aka rotating it 180 degrees, to rotate something 180 degrees, you're just going to make your x coordinate the opposite sign and make your y coordinate the opposite sign. Interesting, interesting, which is the same thing as just rotating 90 degrees twice. So rotating 90 degrees and then 90 degrees again will get you the same thing as 180. Okay, let's say we're at P double prime, and I called it P prime, and we want to rotate it 90 degrees again. So we're at P double prime, and now I want to find P triple prime. I'm going to rotate that P double prime. I'm going to rotate it 90 degrees again. I'm going to take the y coordinate. I'm going to change a sign, so it's going to go from -3 to +3, and then I'm going to send it to the front, and then I'm going to take my x coordinate and I'm going to send it to the back. So I end up at 3, -2 right here. So here's P triple prime. So that's like I rotated 90 degrees one more time. Well, if I wanted to go straight from my original point P all the way to P triple prime, that's rotating 270 degrees. 90 degrees plus 90 degrees plus 90 degrees is 270 degrees. So the rule for if I wanted to jump straight from P to P triple prime is I would take my y coordinate, send it to the front unchanged, but I would change the sign of the x coordinate and send it to the back. So the big idea is I can rotate 90 degrees, 180 degrees, and 270 degrees. And there's 3 different rules that I'm going to show you in just a second. 3 different rules for rotating 90 degrees, 180 degrees, and 270 degrees. But really, as long as you know how to rotate by 90 degrees, you can do all the other ones, because if you're rotating 180 degrees, that's really just rotating 90 degrees twice. If you're rotating 270 degrees, that's just rotating 90 degrees 3 times. So if you're ever doing a rotation on a test or a quiz and you're having an absolute meltdown, like, as long as you know how to rotate 90 degrees, you're good, because you'll just rotate 90 degrees once, rotate 90 degrees again, rotate 90 degrees a third time to get 270. And just to like literally come full circle, let's go ahead and rotate 90 degrees one more time to get, let's take P triple prime, rotate it 90 degrees one more time. I'm going to take my y coordinate, change the sign, send it to the front to get 2, send the x coordinate to the back to get 3, and then, oh my gosh, I end up where I started. My original P and my ending P are the same. So when you rotate 360 degrees, rotating 90 degrees 4 times, you'll end up where you started. Okay, so big idea, unless we specify that we're rotating clockwise, you're always going to rotate counterclockwise. You're always, always, always rotating counterclockwise unless we specifically tell you that we're rotating clockwise. Okay, so our rule for rotating 90 degrees counterclockwise is, if you're starting with point XY, you're going to take the y coordinate, change the sign, send it to the front. XY becomes negative YX. If you're rotating 180 degrees, which is the same thing as rotating by 90 degrees twice, you're going to take your x coordinate, your y coordinate, change the signs, but you're not interchanging them. You're not switching them when you rotate 180 degrees. You're just taking x and y and you're changing their signs. So positive 5, positive 2 becomes negative 5, negative 2 in this example. And then if you're rotating 270 degrees, which is the same thing as rotating 90 degrees 3 times, or you could think of it as like you're rotating 180 degrees and then you're rotating 90 degrees. The rule for rotating 270 degrees counterclockwise is you take the x coordinate, change its sign, multiply it by -1, and then send it to the back. So you change the sign of the x coordinate and then interchange them. So again, these are all counterclockwise rotations unless we specify. Now for 180 degrees, if you're rotating 180 degrees counterclockwise or 180 degrees clockwise, it doesn't matter. You're going to end up in the same spot because 180 degrees is halfway, so it doesn't matter if you're going counterclockwise or counterclockwise.